I'm getting quite a few questions on these extra problems I sent out. This first series, x plus x squared over 2 plus x cubed over 3, etc., converges if and only if. So I apply my absolute convergence test, limit as n goes to infinity of the ratio of the succeeding terms inside the absolute value. I end up with absolute value of x less than 1. So the initial interval of convergence, of absolute convergence, is -1 less than x less than 1. Then I test my endpoints. At x equals 1, it's going to be the harmonic series. It diverges. At x equals -1, I will end up with -1 plus 1/2 minus 1/3 plus 1/4, which is an alternating series, and that converges. So the total interval of convergence is -1 less than or equal to x is less than 1. It converges absolutely on -1 less than x less than 1 and conditionally at -1. All right, next one. Series determined by differentiating term by term. So you had to differentiate this series. And the derivative of the first term, x minus 2, is 1. The next one is 2. X minus 2 divided by 4, or 2 squared. The next one's 3, x minus 2 over 3 squared. So that's going to reduce down to 1 plus x minus 2 over 2 plus x minus 2 squared over 3, etc. There's your general term. Apply your ratio test with the absolute values. X minus 2 to the nth over n plus 1 times n over x minus 2 to the n minus 1. And you'll end up with the absolute value of x minus 2 less than 1. So again, your initial absolute convergence interval would be 1 is less than x is less than 3. I then test my endpoints. At 3, back to this series here, I'm going to have 1 plus 1/2 plus 1/3 plus 1/4. That's the harmonic series diverging. At x equals 1, however, I'm going to have 1 minus 1/2 plus 1/3 minus 1/4, which is the alternating harmonic series, and that will converge. So again, on this, it will absolutely converge on 1 is less than x less than 3. It will conditionally converge at x equals 1. This next problem is a slight little tricky problem, but the coefficient of x minus pi over 4 cubed is, I would take the third derivative of cosine x and evaluate it at pi over 4. So that's where I get my square root of 2 over 2. But there's the term now, square root of 2 over 2 times x minus pi over 4 cubed over 3 factorial. 3 factorial is a constant. So the coefficient of the term x minus pi over 4 cubed is actually square root of 2 over 12. Last problem, 1 plus x to the p, where p is a constant. You're evaluating this as a Maclaurin series, x equals 0. First derivative, p, 1 plus x to the p minus 1. But since x is 0, that's just going to collapse down to p. The second one, p times p minus 1. So you would end up with this as your Taylor series. Pretty straightforward. Hope that helps. See you tomorrow.